the time. But, oh well. All right, so let's get started. We're solving equations. Now, I want you to think about this for a second. Have you ever heard that solving an equation is sort of like unwrapping a gift? You have?
Yes.
Some of you have. Well, that's cool. All right. So the idea here is if I were going to take a gift to somebody, I would have the gift, I would get the wrapping paper. I would put the gift on the wrapping paper, I would fold it over, I'd tape it shut, and then I would wrap a bow around it. Okay? Because it's all about presentation, right? We need a bow. All right? Now, if I was going to get, when you get that gift to the person, what's the first thing they do if they did it in order to undo everything you just did? They take off the bow, they untape the paper, and then they expose the gift. Solving equations is very much like that. An equation has been built, and you have to now unbuild it to solve it. And so we're always going to be concentrating on where the variable is, the variable being the letter. Okay? And you do the opposite of the order of operations. You know, order of operations starts with the parentheses and exponents and the multiply and divide, and then finally add and subtract, right? But when you're working equations, you work on that backwards. You start with any adding or subtracting, and then you go into the multiplying or dividing stage of it. And that's usually as far as you have to go. Okay? So we're kind of working it backwards. Now, another way to think of it, and this is what helped me, because like I said, knowing where to begin was my issue when I was your age. And so I came up with this idea when I became a teacher. I wished I'd have taught myself. I would have been better at it. I know you've been to a family reunion, a party, birthday party, graduation party, an event. You've been to an event of some kind where there was someone at that event you really just didn't want to have anything to do with. Okay? So whether it could be the grandma with the stinky coffee breath and dentures, the grandpa with the smelly armpit, the creepy stalker who's got a crush on you and you just can't wait to get rid of them. Y'all have had that happen. I see. I heard it. Okay. Well, let's use that example then. We're going to have creepy stalkers in our math. All right. Well, and how nice that we use the variable C for creepy stalker. Perfect. All right, so let's look at this first example. And the idea here is you're at the party, and that one person that you want to get away from, the obnoxious party guest or creepy stalker, whichever you prefer, needs to be alone, right? You want to get away from him and you want to isolate the creepy stalker. So let's look at this problem and see how all of these things turn into people and they have lives, okay? So this equal sign divides the house where the party is into two rooms. You have a room on the left and a room on the right. When you don't know where to begin an equation, find the creepy stalker. Figure out which room your creepy stalker, the variable, is in, and always focus on that side first. So if I were to look at this equation, I have the creepy stalker is in the left-hand side, so the variable's on the left-hand side. Who's stuck in that room with that variable?
22.
What kind of 22 is it? Negative. Now remember, we opened a package and we have to unwrap the package, so we have to do the opposite of what we see. You see a minus sign. What do you need to do? A plus sign. And whatever you do to one side of your equation, you have to do to the other. So this example is showing it written sideways, what they call horizontal. There's two ways to show your work on this, and I'm going to show you each way. I frankly couldn't care which way you do it. As long as I can see it, I'm going to be a happy camper. So I need to put the opposite of what I'm looking at here. I see a minus 22, and the opposite of a minus 22 is a plus 22. So there's the plus 22 that's been put into this room with the stalker, and here's the plus 22 that got put into the other room. Both sides of the equal sign have to be treated fairly for it to stay balanced and truly equal to each other, okay? That's why we have to do it to both sides. At this point, we're now going to be adding. Whenever you are combining like terms, you must always add. Even if they're negative numbers, you're still adding them together. Okay? So if I say I have a negative 22 added to a positive 22, you know that opposites turn into a 0, right? So when you add those together, they cancel each other out, and you're left with just the letter C by itself, which was our creepy stalker. So we were successful in getting him by himself. And then we just have to add these guys together. 22 and 54 equals 76. So are you kind of seeing what we did? We did the adding and subtracting first, and we saw a minus sign, so we wound up having to use a plus sign. You do the opposite. Look at the next example. Okay? Find the creepy stalker. Which room's he in? Left or right? Left. All right. So I'm looking on the left-hand side where the variable is. What do you see that's there that needs to be gone? The positive 27 needs to leave, so I need to put a minus 27 on both sides, and then I add them together. So if I add these two together, they create a 0. If I add these two together, I get a positive 3. You doing okay? Okay. Do any of you like kind of the creepy stalker idea to help you figure out where to start? Yeah, it kind of does make sense though, doesn't it? I know. As bizarre as it is.
It just drags it out.
Yeah, so. All right. Now, unfortunately, we can't use a creepy stalker on this one, but we're just going to have to use old-fashioned math. But I want you to understand what's happening. We're using fractions here, and most of you are very unhappy when you see fractions. That's the nice way to say it. Yeah, you hate them. All right. I want you to consider this. Once again, though, we're still looking kind of at the creepy stalker, and we're still going to do the opposite. But fractions are funky. They don't follow all the same rules as everything else. They have a few tricks up their sleeve. So I'm going to cover this up, and I want you to just kind of look at what's there for a minute. Find your creepy stalker, which is the letter G, right? Now, what kind of math is happening between the 2/3 and the letter G? Side by side means they're multiplying, right? What's the opposite of multiplying? Dividing. Yeah. But what's the stupid thing about fractions? We don't divide fractions. Besides them being stupid, yes. We have to multiply by the reciprocal. Okay, so you remember that? Reciprocal, where you flip it. No, not cross multiplying. Don't say it yet. No. Okay. But we're going to get there. Are you listening?
Yes.
Okay, please listen. All right? We're going to get there, but I don't want to get you there yet. As we get down the road and I feel you're comfortable, I'll show you how to get there faster. Okay? Now, we have to multiply by the reciprocal. That's what fractions require. So the reciprocal means I'm looking where the gangster is. G for gangster. Okay. Okay, G for Grant. Now, I need to, shh, don't be distracting. All right? I have to take the reciprocal of what's connected to the variable. So what would the reciprocal of 2/3 be? 3/2. And I have to put it on both sides. And that's what you'll see right here. Okay? Here's the reciprocal on this side. Here's the reciprocal on this side. I would like you to get rid of those crisscross time signs. I need to change that on my notes because we are in algebra. We don't use that symbol anymore. We are going to use a dot. Okay? Now, I have see, this is the original problem right here, right? Okay, and this is the original problem right here. So I've put the reciprocal on both sides of the original problem. And now we're going to multiply these fractions together. When we multiply fractions, we multiply straight across, okay? So if I did that here, 2 times 3 is a 6. And then 3 times 2 is a 6. This whole mess right here turns into 6 over 6, which is really just no, it's not a 0. It's a 1. And then 1 times g is just a g or a 1g, right? So that's the magic that happens when you multiply a number times its reciprocal. It cancels everything else out and turns into a 1. But you have to do it on this side too now. So we're saying 1 times 3 is a 3, 2 times 2 is a 4, and I have finished my problem. So it's not that difficult, but it does take a little time. Flipping and putting the reciprocal on both sides and multiplying straight across, okay? Do you have any questions on that one? You good? All right. Now we're going to look at example 4 here. Okay. Find your creepy stalker guy. Find the variable. This time he's on the right-hand side. And who is with him? A -3. What kind of math is happening? Side by side, they're being multiplied. Okay? What's the opposite? Division. So I have to divide. Now remember, I want to leave the variable there. I want the 3 to go away. So it's the 3 that I have to divide by. And I want you to look at this next row because this is important. You often will see this in your textbook, the negative sign equal to the division bar of a fraction, right? I am begging you, and if I had a good knee, I'd get down on it. I truly mean this with all my heart. This is one of those things I really, really want you to make a habit of. I want you to never do that again, and I really would like you to put it in the numerator with the number itself. There's a reason for that. And the reason for that would be if you don't do that, you're very apt to use that negative sign more than once. You'll give it to the numerator, and then again you'll work it on the denominator, and you will mess up your problem. So only let it be in one spot. So at this point, now I've put it up here. Now I'm going to divide by the -3 on both sides. When you do the math, you get the -13, and these guys cancel out to make a positive value of 1. And you're finished. Now, proper algebra would tell me that I should write the variable first. Okay? Are you okay with that idea? Okay, let's see if we can I'm going to help you walk you through the beginning of this first try it, because I want you to kind of see what's wrong with it. There's nothing really wrong with it, but your eyes don't like it very much. Why is that? It's a fraction. Okay, but where's the variable? On the k. So who's connected to the k? We want it gone. It's a fraction. What do I have to do to it? Reciprocal. So we're going to write the 5/3 on this side, and then we're going to bring the 6 down and write the 5/3 on this side. So there's the reciprocal and the reciprocal. Okay, what's going to happen to this side? It crisscross applesauce, it's gone, right? It's a 1, so there's the k. However, this is weird looking. Who said that? Okay, good. All right. Visually, mathematics will be easier for your brain to take if the things look alike. So when you have numbers that are in different forms, see if you can put them into the same form, and it will actually make more sense to you. They are having a cow next door. Okay. All right. So, here we go. I put a 1 under it to create a fraction. It looks a little easier now, doesn't it? It's not weird to your eyeballs. So now we can just multiply straight across. No, straight across. 30 over a 3. Is that simplified?
No.
I can divide 30 by 3, so that would become a 10.
15.
Okay. All right. Do you have any questions on that one? No? Okay. See if you can do... Yeah, yeah. You should always simplify. That's it. 10. Okay, sorry. All right, try the next one there. Find your creepy stalker, find the variable, see who needs to leave, and make sure you do the opposite of what you see. There's the wall. How many of you are visual learners? Have you taken those tests where you do better visually? Okay. If you are a visual learner, I would please, and my students tell me every year that makes a huge difference to them. If you will draw the wall, I know it sounds stupid. It really helps you see the sides of the equations better. It really does. So if you struggle, draw the wall. Okay? All right. Once you've drawn the wall and you've found your creepy stalker variable, who wants to leave? What kind of 12 is it? It's a negative 12, so what do I need to put? A plus 12 on both sides, right? Opposites turn into a 0. And this becomes 28. Now, is that a great answer?
No.
Or is this a good answer?
That's bad because it's a negative p, and you don't have negative variables.
You read the bottom of the notes. Good for you.
Yes, I did.
I'm glad.
Yeah, and I did this like 5 minutes ago.
Okay, good. All right. You are never finished if you have a negative variable in a final answer. So if that were a multiple choice test, right, and one of your choices was negative p equals 28, do not pick it as an answer. It's not finished. What number do we assume to be in front of this variable?
1.
A 1. All right, so if I were to put a little 1 right there, I can now see it. Could I divide both sides by that negative 1?
Yes.
And then I will have a positive answer. So watch. If we put a negative 1 on both sides, the two negatives make a positive, and now the 28 is the negative guy. And you finished it. Are you feeling pretty okay with this so far? So far, not too bad? Well, good, because we're almost done with the notes. And you haven't been crying yet. It's good. Let me see if I can make you cry. Let's look at the next problem. All right. Now pay attention, because many of you are going to want to do something you shouldn't do. Find your creepy stalker and draw the wall. There we go. What is it you want to get rid of? The negative 1/2. What are you going to do? Multiply by the reciprocal or put a positive 1/2?
Put a positive.
How many of you think you might multiply by the reciprocal because it's a fraction? Right? Okay. That's where you have to be very careful. What kind of math is happening between the creepy stalker variable and this negative 1/2? Are they being multiplied together? If they're not being multiplied together, you don't do the reciprocal. Okay? The only time you do that is if they're side by side and you have to divide. I just made that up, by the way. Side by side, you got to divide. But they're not, so we're just going to add or subtract. So here's a negative 1/2. What will I need to put? A positive 1/2 on both sides. Adding these two together will create a 0. And now, if I didn't grab a calculator when I first came into the classroom, which I should have done, you're not getting one now. We're going to have to find a common denominator. So, to find your common denominator, look at the smallest denominator. Will it divide into this one? If the answer is yes, you can use 8 as the common denominator. Sit down. Nope, you don't get to use it. If you didn't get it when you came in, I'm not letting you get it now. Yes, sir.
I thought you had to flip them.
No, we just discussed that. It's not multiplying. It's not multiplying, okay? All right. When I taught 6th grade math, my numbers are people. They wear shirts and pants. This is a shirt. This is a pair of pants. This is a shirt. This is a pair of pants. Okay? Tops and bottoms. To make these guys match, this guy had to put on a new pair of pants. Right? If you put on a new pair of pants, don't you need a new shirt or you're going to look kind of funky? Yeah, you got to have a nice outfit when you get done. So, if you're changing into new pants, you have to change into a new shirt. What did you multiply by to make the new pair of pants? A 4. That means you multiply the top by that same number to create the new shirt. That's how we taught fractions in the 6th grade.
Is that completely different?
Now, we're going to add our fractions together. 4 things plus 5 things makes how many things?
9 over 8.
9 things called eighths. And you're finished with your problem. You don't have the denominators. Yeah, it's kind of like a variable almost. It's kind of weird. It's like a label. Okay? How are you doing? All right? Okay. I want to show you one thing. Shh. I want to show you one thing. On your homework, I believe it's problem 46. You should pull this out so you don't see all my sunspots. There we go. All right. I believe the problem is this. Okay. All right. This is what problem 46 looks like, and this is where students have asked me, I'm stuck, so I want to give it to you now. You can rewrite this problem, and you can rewrite it to look like this. Remember, we assume there to be a 1, right? So we're going to write it as 1 over 24, and then put the C off to the side. Can you now think about what you'd have to do next. I'm trying to get the creepy stalker alone. What kind of math is happening between the 1/24th? They're multiplying, but we have to divide. So what's that really mean I need to do? Flip it. To put the reciprocal on both sides, okay? So now, if this was the problem, and I'm going to multiply by the reciprocal, and this is the problem, and I'm going to multiply by the reciprocal, you can kind of see how you wrote this problem now to look like this problem, okay? And I'm going to leave that up there for you for a minute or two. Huh?
There, that is cheap.
I know. So,
That's the work in everything.
I know.
You need to just put that away.
I know. All right. So, have you any questions for me? You good? You think it's going to be okay? All right then. I'm going to put up the answers so you don't have to open your Chromebook to see the first 3 or 4 answers. If you are not getting the correct answers before you leave here, you need to raise your hand and let me help you, okay? Yes?
You mean like we're not working them out right?
If you don't get the answers, then you need to check with me before you leave here so you do get them correct.
I thought you
Okay.
meant there was something messed up.
No. Okay.